Shandas. I'm a professor and founding chair of the Department of Bioengineering at the University of Colorado, Denver, on the Anschutz Medical Campus. This session, when I was asked to moderate this session, I thought about, what you're going to see here, and it really kind of reinforced in my mind why I decided to become a bioengineer. When I graduated as a electrical engineering undergraduate, I wasn't sure what I wanted to do. I got a job to go work at a very large defense subcontractor, but I met a patient who had a cardiac pacemaker implanted in him. And I got a kind of sense of how his life changed as a function of technology, and that's one of the reasons I decided to become a bioengineer. And it's one of the things that I try to teach our students as well in our department about this idea that you're not just designing technology, but you're designing technology for very, very important particular purposes. So we talk a lot about how do you design technology for the user? What is the user for a biomedical engineer? And a lot of the time we talk about the clinician as a user. The clinician ends up using the technology that we develop. But this is a very interesting idea to me, in that what you're going to see here is that the client, the human being, is the ultimate user. And as a technology developer, for me, it's tremendously gratifying to see that an engineer like Scott has been working with a person like Amanda, and together they're coming up with a solution that is pretty extraordinary, pretty transformative. So this idea that, how do we create not just the science of technology, which is what I work on, and I work with physicians on the science of medicine, and I work with biologists on the science of biology. And we bring those three things together to try to improve people's lives. But really, I think we need to incorporate, and this is something I'd love to keep teaching my students, how do we incorporate the humanity, the science of humanity, into our design? And I think that's really a large part of what you're going to see here. So with that, I just wanted to make those brief comments and introduce Amanda and Scott. Both are extraordinary people. I think you'll get a real sense of what they've accomplished, and I will go off and sit down and let them take over.
Thank you, Robin. Oh, let's not start the slides yet. Can we just back up a bit? There you go. So good afternoon. Thanks for coming today. I wanted to throw a question out to the audience. What defines us? I've been paralyzed for 22 years. The wheelchair is a universal symbol for disability. But does it define me? I'm on a roll. I'm inherently labeled as being disabled. But we have an opportunity to redefine disability. Is the word disabled empowering, or is it disempowering? Think about it. We are unique, yet we're the same. We have an opportunity for us to all aspire toward optimal health and well-being. Isn't that what we all want? But what if our common language was somehow a quest for quality of life, freedom of movement, and what makes us as an individual is freedom of self-expression? I'm a woman, I'm a girl, I'm feminine, I like fashion, I still shop for shoes. Why not? So I ask you to step into my shoes. I want you to try a really quick exercise for me, and while we're a scattered, semi-scattered audience, try this on for perspective. Every second person stand up. So what I need is I need one person standing and one person sitting. So do it really fast. And if you're not near someone, just quickly go over and stand near someone. So one standing and one sitting. Perfect. Now turn around to that person and shake their hand and introduce yourself. Okay, perfect. So those people who are sitting, take note of what your new normal is. What's your new normal? Just think about it. Take note. The ones that are sitting. It's navels and nostrils, right? Navels and nostrils. Okay, take a seat. I wanted you to feel what it might be like to be in a wheelchair. Think of what it's like to live with this day to day. What it might be like to go to a cocktail party and always be looking up or at this level. To feel claustrophobic, to feel daunted and dwarfed. 1.3 million people are in the United States who are affected by spinal cord injury. I represent 1 in 50 of those who are paralyzed in the United States. That's 6 million. 1.6 million have had a stroke. That's the greater percentage of that population. With spinal cord injuries, any neurological disorder, or stroke, the market is expanded to those that really need an assistive device. So we have the potential to change this, to introduce a new mobility option for the first time in the history of movement. Now transport yourselves back to a moment in time that was beautiful, where you felt carefree and you could conquer anything. What would you give to relive that moment? I was 24 years old. I felt invincible. I was in athletics, captain of my school. I was a dancer. Did it go? There you go. An aerobics dancer. I was a ballet dancer. That's ballet, not belly dancer. I used to run on the beach. I was a skier. I hiked amongst wildflowers. It was my favorite thing to do and what I long to do to this day. I ran on the beach. And all of that changed in a really quick second. It was a moment in time while I was downhill skiing, and a freak somersault shattered 4 vertebrae. It also shattered the illusions of my own immortality. An electric current zapped through my legs. They crumbled on top of me, and there was nothing. I was paralyzed with no sensation from the pelvis down. It can happen just like that to any one of us. A couple of weeks later, I was in a hospital room, and a doctor strode in, and his face screamed medical student. His face was younger than mine. I was 24. And he was sent to deliver the bad news, and he said, "Amanda, you'll never walk again." And I became determined to prove him wrong. It took time for me to turn my wounds into wisdom, and for me to remove any self-imposed limitations, and to really embrace my life, to live it fully and happily. When someone sustains a spinal cord injury, it's so much more than not being able to walk again. It's a cruel injury. I grieved the loss of my legs. I grieved not being able to pee on my own. Bladder bowels, people may not be aware of that, but that's something that I lost, that function. Digestive system, swollen ankles, neuropathic nerve pain, poor circulation. We're prone to osteoporosis, brittle bones, joint contractures. muscle atrophy. When we sit, our bodies begin to die. There's every reason now to prepare your body to walk again, because we can. I went on and I learned how to ski again, to hand cycle, paraglide, hang glide, rock climb, kayak. Yet nothing had been invented that could enable me to learn how to walk again until now. I received a phone call that changed my life. I was invited to test pilot a bionic exoskeleton suit. It was a prototype. After 18 years of paralysis, my dreams burgeoned to life in one precious moment. I stood up. I felt the tallness in my 5'7" frame. I could look to the very back of the room. Something so simple that we take for granted. Everything happened. I heel striked. I pushed off from my toes. I was determining my own step. I was walking in what has become the most complex neuroprosthetic ever created. It's difficult to get a robot walking, but to get a paralyzed person inside of a robot walking, that's the ultimate challenge. And I did it. But how does this functional apparatus work? Think of our internal skeletal system, our endoskeleton. We have the bones, we have nerves, muscles, joints. And that translates to what we call the bionic exoskeleton suit. So the outer shell of the exoskeleton mimics my internal bone structure. There's 6 joints, just like your ankles, your knees, and your hips. And just think, we need nerves that then communicate to our spinal cord and our brain. Just like our body, the sensors on the robot send signals to the computer, which is the brain for the robot. But then we need power and strength. So there's 4 motors. And just like your muscles power you up to stand and walk, these motors power me up and enable me to stand and walk. But let me take it a step further. What if this functional device could not just be utilitarian and mechanical? It's really cool. But again, I'm a girl. I like fashion. What if it could become this really amazing outfit that was a kinematic art form of design and beauty, where we created the ultimate fashion statement? Why not? And that it fitted seamlessly with my own body, just like a glove, and it became an extension of our senses. For that is our dream. We share a dream to power any person up who has a musculoskeletal challenge, to give them freedom of mobility, quality of life, but also to wear something that is fashionable, that they're proud to wear. Again, I'm feminine. The wheelchair has its limitations, but while I really love my robot, I want it to become an expression of me. What if it became like the ultimate cool bicycle, or the sports car that is sleek and sexy? What if it was truly an extension of me, and from me, designed from my own body? What if I was an active creator in the design process itself? What if this amazing, cool technology could just simply become an expression of my own personality? And it fits seamlessly with me, wrapped its arms around me as though it was giving me a hug, just like a friend, and not something that I just strapped on, but it became one with me. We have to feel empowered to become co-creators of the design of our future and designers of our own health and how we interplay with that. I ask you, as you sit here, not to look at what we have right here, right now, and ask why, but instead dream up the unimaginable. See things that never were and ask, why not? I'm going to turn it over to Scott, my colleague, who's going to take you through this amazing process that I became a part of.
Hi. So to give a little bit of a backstory to how this robot came to be, I'll throw out some ideas that we've been working on for the last 5 years at a company that I started. Started this company 5 years ago thinking we have opportunities to take otherwise medical products and transform them, take away the baggage of a medical product and all that means and all the connotations associated, turn it into a design product. And in so doing, you can actually sometimes really improve the quality of medicine. And so that was the premise that we set out with. There are already products in the market like that. You know, we know that eyewear, it's a medical prosthetic device, assistive device, but the connotation is not deficient vision. The connotation is it's fashion. It's made the leap. It's one of few that have, but many others stand to. So about 5 years ago, right after we got our first round of venture funding with these ideas and some early prototypes, we had an incredible stroke of luck. Our lead investor, his daughter fell off a swing and had a non-displaced fracture on her radius. So that was amazing good fortune for us, because she then, within a week, became the first person ever to have a 3D printed fracture brace based off a 3D scan of her arm. And so anyone actually who's in the back might want to come forward, because the slides, the details where the interesting stuff is. So just throwing it out there. The idea wasn't simply to be different for the sake of being different or to do something traditional in a new method using today's technology. It was to make a better cast in every way, something that breathes, that's comfortable. In fact, we made her two. We made her a second one that we metal plated in polished nickel that's biocompatible. And the goal was to see, could we actually make something that's indistinguishable from jewelry? And sure enough, all of her friends in school wanted one. They asked her how they could get one. She said, you can get one, it's just gonna hurt. And she didn't want to give it back, strangely enough. When's the last time that happened with a fracture cast? We had amazing luck a month later when another investor had 2 daughters fall down the stairs and break their tibias. And so this is manna from heaven for us here. And it was completely successful. They healed. It was really hard to get investors with kids after that. They figured there's something karmic going on here. But sure enough, the kids healed. They healed very well. On top of that, the surgeon, the peds, all said, well, the hardest thing with pediatric fracture is not casting it. That's easy. It's the buzzsaw to remove the cast. A 2-year-old, this is a 1 and a 3-year-old, they're not really fond of the buzzsaw, and sometimes that actually causes more problems sawing it off than stabilization in the first place. Well, this is a hinge. It's a clamshell. It just comes on and off, and then they can take a bath. In fact, we made them duplicates, just like we did for Anais, the previous one, so they could throw one in the dishwasher, and every time they ran the dishes, they cleaned it, and it kind of a poor man's autoclave, and they got a clean, warm cast to sleep with that night. So there was never all the problems associated with cast. So emboldened by those successes, we went into scoliosis. Now, scoliosis is something that is entirely compliance-based, 86% compliance-based, meaning that if the child does not wear the brace, they won't be fixed. meaning if they don't like the brace, they won't wear the brace, meaning the goal is not a medical one as much as it is a fashion one. So we set about to say, okay, let's reinvent the scoliosis brace, not the medicinal component, the way it morphs the spine, but instead the design of it, because we just need to make the kid want to wear it. So we created a process where we 3D scanned the girls and designed them, corrected them digitally, and 3D printed the scoliosis brace. What that does is it gives us something that's invisible under clothing. So we respect their desire for discretion while they're going through the process. It's a huge thing with 10 to 12-year-old kids. Then we made it so that when friends do see it, it looks really good. It actually accentuates them. It looks like a corset. There's a pattern on there. And the pattern makes it's 40% open area. So their skin is breathing. So they can maintain homeostasis better. They're much more comfortable. They don't heat up in hot weather because their skin's actually breathing. They're not sweating all the time. So the goal was to take this and think of it as a fashion device that happens to have a medical component to it, not a medical device that we're cleaning up. And our hope now is to convince insurance companies that increased compliance leads to less spinal fusion surgery, and so the net is that less out-of-pocket pay for them at the end of the day. That's a bigger challenge than all the technology combined. Everyone here, I'm sure, knows that one. So to treat it as a real fashion detail also, we gave them patterns. So the patient gets to be a co-owner, not only because their body is scanned to create the product in the first place, but because they get to choose the pattern, what kind of lace pattern or filigree they like that becomes part of their design. We extended the same idea to carpal tunnel and CMC arthritis bracing, and we invented a scanner and a software that runs with it, so you can put your arm in, instantly scan it, circumferential scan, it parses the data, sends it to the cloud, and prints you a perfect fitting CMC arthritis, carpal tunnel, a number of different RSI braces, based on your geometry, perfectly fit, and you get to choose the pattern so that you're more likely to wear it. Again, these are all functions of compliance. If we can increase compliance, we can increase the outcomes. Prosthetic limbs have always been one of my key areas of focus because it seems that if you lose a limb, bad enough, but if you get one of these, that's insult to injury. It's such an odd juxtaposition of mechanical parts against the fluidity and the grace of the human body. So I wanted to address that again with the technologies of 3D scanning and 3D printing and this idea of co-creation, of giving agency of the design process to the end user. So we started with Deborah here, 3D scanned her other leg, worked with her on the pattern, on the lace pattern, the filigree, and 3D printed it. And what we're able to do with that is change the conversation from Deborah being a person with a prosthetic limb to a person with two different legs. One of them is really beautiful in one way, one's beautiful in another way. So all of a sudden she started wearing skirts again. And we're able to really shift the focus so that it's not about disability. We're able to actually reify the body, create a shape that is very accurate to what is gone. So we're able to, in a sense, pay homage to the limb that's lost. We're able to customize it in a number of ways as well, because again, that's the versatility of 3D printing. In this case, we're recreating a tattoo that he always had in the back. You can even see down just on his Achilles there. There's a number 7 there. It's curbside recyclable. So it's about shifting the focus from the prosthetic limb and the difference and the asymmetry back to the body. We're able to incorporate somebody's life into it. So in this case, this is James' lifestyle. It's how he lost his limb, but it's also a big part of his life. And so we wanted to blend it in so that you can't tell where one starts and the other stops. It becomes a hybrid of the two. Or Chad, we let him play soccer again because his brain actually remembers the morphology of his leg and remapped it. So he was able to feel the ball as he used to. He didn't have the same kind of dexterity kicking and such, but he was able to actually play again competitively. And then we created another leg again, not to blend in or not to trick anyone into thinking that he's not an amputee, but something that, again, is unapologetically man-made. It's meant to be deliberately designed. Now, the 3D printing process is a bit idiosyncratic. There are vestigial artifacts you can see there in the modeled texture. And if anything, that makes it actually, I think, more natural when juxtaposed against the human skin, the human body, than something that is perfectly well man-made. We wanted to treat every part as jewelry so that it looks more like fancy, unusual jewelry than anything that has any suggestion of a medical product. Or we wanted to capture a person's identity. In this case, these tattoos that really helps define him. That's what he wants to express in the world. So we recreated that in his prosthetic limb. And debossed it into the back. So it becomes an expression of him. He's able to, again, express himself through his prosthetic limb. An actress in Hollywood asked if we could create fishnet stockings. So we created 3D printed fishnet stockings that were chrome plated. And now she actually buys clothes to match her leg. The bigger goal from 6 years ago that we started with is to see how we can extend this technology to the rest of the world, because the gulf between the number of certified functional prosthetists in the world and the people who need access to those people is only increasing. You know, it's bad and it's getting worse. If we continue the current trajectory, that gulf only gets wider, right? So we have to start thinking about, how do we get exponential? How do we change in a very different way? Traditionally, or recent traditionally, that means going digital. So the idea is to say, well, can you create a software? This is what we've been working on for a long time now. Can you create a software where you can 3D scan the person's body with nothing more than an iPad? That's all possible. Scan their residual limb and their sound side limb. Run the data into the cloud, and it results in a 3D print ready leg that can create essentially the perfect leg. In this case, a 7-bar linkage, but a 4-bar is probably the way to go. But a multi-bar linkage complex leg, fully load-bearing, recreates symmetry on the body. Here are 2 of the original prototypes. They got quite a bit of walking in while we were testing them. And it is made locally, incredibly low carbon footprint to create, because it's only a laser and some powder that creates it. It is curbside recyclable and dishwasher safe. Go figure. But the potential is that because this is a digital process, and it could simply be no more than an iPad app, it could be one of those things that goes exponential, that can go out there and scale at a rate that doesn't depend on the certified prosthetists of the world, which will never really reach the numbers that are needed. So the goal here, again, was to distract from the idea of this being a medical product and to think of it instead as a design and lifestyle product. And that shifts the focus, rephrases the question. So that's the backstory. We met Amanda a year ago after we'd been working with Ekso Bionics. My company was acquired by 3D Systems, which is the leading company in 3D printing. And I was having lunch with the CEO, and we were over meeting with Ekso Bionics, and in walks Amanda, or rolls Amanda. And we asked her to join us for lunch, and she starts explaining her ideas on what she would like to see. You know, the robot's great where it is now, but here's where it wants to go. And he was very excited to hear everything that she had to say, all these wild ideas. And when she left at the end of lunch, she turned to me and said, okay, do whatever you have to do to make that happen. And let's see it through. Let's, you know, which is kind of music to the ears when it's a $10 billion company and the CEO says, all expenses, make it happen. Great. So we set about diving into this process and realized, okay, we're going to get there first with baby steps. The big vision is ahead. We're going to get the baby steps going first, which is to create the interstitial parts that connected Amanda to the robot using her own body, using a 3D scan of her body to create those parts. The original research that I was doing 6 years ago, that meant $1 million scanner, or at least a $30,000 scanner, depending on what you did. Awkward, cumbersome, expensive process. Now we did it with a $400 scanner that you can buy at Office Depot. That speaks to kind of the change of technology that's going on now. We 3D scanned her body in a range of positions. Sitting, so we could capture her so she'd be comfortable while sitting. Standing, we morphed the geometry together. And then we started designing the parts. And the idea with the parts was to, again, not make it feel like a robot, to steer away from the mechanical aspects, to really play up the fluidity. We're also able to, at the same time, create parts that were ventilated, because by creating the filigree pattern there, we're able to let the parts breathe. And then we wanted every part to really stand out, speaking to the fluidity of lines, not an articulated mechanical product, but something that suggested more the ligaments and tendons and the qualities of the body. We wanted each detail of it to really suggest the musculature that it's replacing, to kind of become a visual metaphor for musculature that's been enhanced. And so the parts are 3D printed. Now we're using something called polyamide nylon. It's selective laser sintering is the process. It's used a lot in aerospace and Formula One and whatnot. It's extremely strong, extremely lightweight, durable, and you can print any kind of geometry you can dream up. that kind of flexibility of geometry for a designer is perfect because we're creating parts that would have been prohibitively complex any other way. And not only that, we had 3D printers in our studio, so every night we would design our parts and then 3D print them, check them in the morning, and do all kinds of ergonomic testing, fit and form check. And so we really knew what we were getting into. And just to add that last little detail, I'm assuming that's a good sound.
Sorry.
To add that last little detail, we 3D printed sterling silver because we just decided this is a robot, and we talked with Amanda about this, decided that the robot needed a little bit of bling. And so that's what robot jewelry looks like. And so in the process of this, we actually took out a number of the parts of the robot. We added the 6 that you see here, but then we removed many more because it's called part consolidation. We can make a couple complex parts replace many, many simple parts that otherwise would have to be bolted together. And with that,
Are you ready?
are you ready?
No, almost though. It's
So what
really,
is it
I'm
for me?
having more difficulties with the microphone than the robot. Just let me put this microphone on. Angie, I'm going to have you help me with this microphone. Actually, I'll just put it.
Okay. We might as well do a question right
There
now
you
while we're at
go.
it.
Okay.
When I started, the company was called Bespoke, and we were 5 people. It was me and my business partner, who fortunately was an orthopedic surgeon. And that helped with the whole process and insurance companies and all the details that required. We grew up to, I think, 6 or 8 people by the time we were acquired 2.5 years ago. We were acquired by 3D Systems, and now we are a research group within 3D Systems looking at everywhere from how the body relates to 3D printing, all the different medical and exoskeletal applications, but we're also involved in 3D printing in outer space, 3D printing food, musical instruments, R&D of all kinds. So we're kind of a blue sky skunkworks within 3D Systems now, and we're based in San Francisco. We're
Okay.
ready to roll?
We're ready for the moment.
Okay. Just to be safe, I'm going to drop the mic and get ready just in case. We're on carpet here. It's anyone's guess.
Okay. Here we go. Yes. There you go. Thank you. So let me take a few steps, and as I step out, I can walk and talk at the same time. The walk and the gait for this device is very fluid. It resembles a natural human gait. So I'm able to strike my heel on the ground, and as I actually take a step, I'll show you really quickly how it works. When I spoke about the joints and the sensors and the motors, the computers on the back, I'm actually putting the robot into a walk mode. As I take a step, the device is not going to take another step until I've shifted my weight correctly. So I've made my forward target, but when I hit the lateral target on the side, it'll take another step. So when I walk and I stand tall in front of you, it's emotional for me too. A nice role reversal's happening. I'm standing and you're all sitting. So I get to look at the back of the room. I get to feel the tallness of my body. I get to feel like Amanda. But not only am I in this beautiful device that is functional, utilitarian, but I feel pretty sexy in it. I can strut my stuff on this stage because it's part of me. The 3D printed parts are all the white parts, and it follows the curvature of my spine. It wraps around my body, around my kidneys, just like it's giving me a hug. And I'm very proud because I was an integral part of the process. And I throw it back to you. This is my body. I ask you, would you allow someone else to design a tattoo for you? Take charge, take responsibility for choosing your own path. Remove any self-imposed limitations and become a co-creator of your experience. When I stand up in this device, I feel like a veil's been lifted from my head. I can think more acutely. My digestive system operates more fluidly and regularly. I'll go to the bathroom right after this presentation. It's great. It gets things moving. And so I have better circulation as well. But the coolest thing is that my neuropathic nerve pain dissipates completely when I stand up. So I have the physical benefits, but I also have the psychological benefits. I'm eye level now. I no longer have to look at navels and nostrils. I can go to a cocktail party, but I can also feel proud because I'm wearing the ultimate fashion statement. So I'd like to invite Robin back on the stage, and I'm sure he has a couple of questions for us, and then we'll throw it out to the audience. Thank you.
So one of the things that I decided to do when I heard that I was moderating this session is I sent an email to all our students, and I said, you know, so if you wanted me to ask both of you a question, what would it be? And pretty much the overwhelming response was, what would your, both as a technologist and as a co-creator, what would your message be to students who are studying this field? And you know, so they have great dreams, like you talked about. They have great dreams about changing the world. What would you tell them?
I would say first thing, get an art degree as well.
Yeah.
that sounds anathema to anyone in a BME type program, but I think that there is an advantage that comes from the arts that you might not have in medicine specifically, and that when you start thinking of the person and really creating a design that is based that intimately on the person, it maybe will take you a different place.
Right.
We're also in an exciting age of innovation, where all of a sudden funding is more available than it ever has. Prototyping, testing ideas, exploring ideas, that has never been easier, you know, in history. So this is an ideal time to be anybody as a designer or innovator in medical space, consumer products, you name it. We have more capability of doing the world-changing stuff than we ever had in the past.
And I wanted to say that I think Scott and I were talking, and so often we get caught up in the gee whiz factor of technology. What can it do? What's the next part? Neural interface, brain-machine interface, thought-activated technology. But then we forget about self-expression, the human element, and bringing humanity back into the medical device. So the sooner we can bring the person, the students, as soon as they can interact with their client, with the person, that this is something that I eventually would like to wear every day, all day long. It becomes a part of me. It becomes me. It's built from me and for me. And so that's what I'd encourage them to do, is to bring them in as soon as possible and weave in humanity into the equation, so that I'm just not going out as a consumer and choosing something off the shelf.
Right. It's a tremendously disruptive idea, I think. So we will have some time at the end for some questions, but one of the other things I wanted to ask you was, so it seems like both figuratively and literally this is kind of the first step in this technology development. Where do you see kind of things going from here?
The thing is that when you look at this, yeah, you are looking at the Edsel, not the Ferrari. This is a very nascent technology. 3D printing has only been around 20 years, and only practically in the last 5 in what we're familiar with. The robot is, 4 years old that people have been walking in it. So this is very, very early technology, and its trajectory is exciting. And it's a fun time to start brainstorming where this can go. Project out 10 years, as the premise of the conference is. Where can things go? We alluded to this 2 nights ago, that it's the confluence of 3D printing and robotics and nanotechnology. When you start blending those together, there's some really exciting opportunities are ahead. The conversation that Amanda and my CEO and I had that day at lunch a year and a half ago was not about the current skeleton. This was meant to be a first base. The thinking was, okay, what happens when we really, really, really push it out into the next generation? So I
Scott
brought some
gave me
slides that
permission
show that.
to dream. He said, Amanda, just like think big. Think what's your biggest, amazing, most amazing idea?
And the response that came back was, okay, it shouldn't be this articulated robot sometime in the future. It should be a second skin. And that conjures all kinds of new images. It shouldn't be something that's obtrusive. It should be lifestyle transparent. Something where all of a sudden paralysis is an inconvenience because the device picks up where the paralysis is taken away. So I can show a couple pictures that we brought that kind of articulate this point. This is the idea that Amanda had thrown out. What happens if this exoskeleton is instead snakeskin? If it's something that you pull on. This is actually a 3D printed mesh. We passed one around here yesterday. You can 3D print complex mesh structures now. Right now they're passive, they're dumb, they're interwoven. But what happens when you can motorize this mesh and distribute the intelligence and the power within this mesh so each voxel there has its own power and its own thought process? What happens when this robotic exoskeleton doesn't look like this, but it looks like this? Exactly. We can print exotic metals now. Very, very high definition exotic metal. What happens if the first step of creating an exoskeletal robot is to 3D scan the body so that before all the technology fuses into it, her body is the first ingredient, and then we print this kind of mesh, and the mesh simply pulls on like fabric. This is already being done in test cases and prototypes of all kinds. This is, I think, one of the most exciting new developments in this area. Can this video roll? Is the video not loaded? It should roll automatically. Okay, short of that, one of the most exciting things you can check on is done by Nervous System out of MIT in Boston. It's a group who has been looking at being able to take a 3D scan of the body and 3D print an articulated fabric 3D printed dress out of it. This is already being done. This is today. So the next step is to then convince this fabric to act in a swarm mentality, like swarming robots. We're seeing a lot of that now. That's a hot topic. But let's say each voxel in that fabric has the ability to swarm, to be proximity aware, and to have distributed power, and to start behaving as a collaborative overall unit. This is one of the first concepts we were looking at. This is as far as we got because we realized that the technology to make this happen is still quite a ways out. But this is the long-term vision of where we would like to take the robot.
He expressed it perfectly. I envision literally slipping into this device. It becomes the undergarment of our future. It's my second skin. As a snake skin sheds his skin, I might too at the end of my day. But it's soft, sensual, sleek. It constricts, works with my own musculature, and powers me up, gives life to my limbs. So now we're talking about the convergence of new technologies. We're talking about robotics, nanotechnology. We're talking about smart materials and 3D printed components. It will be a combination of these things. And these scales work together symbiotically with my body. So is that a way out vision? I don't think so. We're just going to see this getting smaller and smaller, less and less, so that we can see more of Amanda and less of the machine. We can template drive this. We can mass produce it and have it for children and the elderly.
Shall we take questions?
Yes.
Are there limitations to your being? Okay. This is so impressive. I'm in awe sitting here. Are there limitations to your being able to put that on every day now and wear it for hours?
I must emphasize that the device that I'm wearing right now is an R&D project. This is not a manufactured device. I am walking in a partially 3D printed exoskeleton. All the white parts are the 3D printed components, but it's a rehabilitation device. So it's to be used functionally, and when we restore it back to my original form in the robot as a functional exoskeleton from Ekso Bionics. It's a rehabilitation device that walks on flat terrain. I always need Angie, a physical therapist, to spot me so that I don't fall. And but it does power me through. I have trace muscles in my legs, and when I say trace, I'm able to just move them just a tiny bit, not enough to power me up to walk on my own. But this is a rehabilitation device in the sense that I can work up a sweat. I can use whatever I've got to contribute to my step, and the robot's intelligent enough to help me finish my step. So that's why it expands to stroke. We can actually turn off half of this robot, and for hemiplegics, the affected side can get the gait patterning that it needs, and the normal side gets to just walk naturally. And so that's where it's the ultimate gait rehabilitation device. So next year, a couple of other manufacturers are coming out on the market with Parker Hannifin and their Indigo design, and then Ekso Bionics is going to come out with an individualized robot or exoskeleton to be used more and more for daily living. So it's happening. The future is now. Even though this is rehabilitation, we are able to look toward the future and look to how we can individualize this more and more. Yes, Pamela. Hi.
It's great to see you up again.
Thank you.
Can you talk a little bit, thank you. Can you talk a little bit about how this kind of device is being used in hospitals for rehabilitation for more than one person at a time? How that might work with...
Yes.
Yeah.
So, and that then, once we take off the 3D printed parts, we restore it back to a functional device that's fully adaptable, fully adjustable for someone who is anywhere from 5'2" to 6'3". How tall are you?
6'4", so I'm on luck.
It's 6'4". No, we've actually had someone who's 6'4" stand in it. So it depends on the leg length and your torso length and different variables. And he was a man that stood with his 5-year-old daughter. She had never seen Daddy stand. And his wife forgot that she had to give him a kiss, stand on her tippy toes to give him a kiss. And so it's not just about the person in the end user, but it extends to the family members as well. And so this is a device. There's 60 of these around the world. We're looking at getting one in our valley right here as well, through the Bridging Bionics Foundation. And it just brings to mind a quote from Christopher Reeves, and he said, any technology that has any substance behind it begins with an idea and an individual, and that individual talks to another individual until it becomes a movement. And I believe that we are the spark behind that movement with Bridging Bionics Foundation, and then collaborating with different companies like 3D Systems, Ekso Bionics, to bring the technology to the people.
I think there was one more question back there.
Benzie Kluger from University of Colorado. A neurologist had a couple questions. One, so it seems like it's the residual muscle that triggers the robot. Is that correct in terms of getting the gait? Is that what?
So my musculature doesn't really have anything to do with it. My role with this device at the moment as an end user is simply to find where I am in space, my center of gravity, and to shift my weight correctly. So when I shift my weight correctly, there's sensors throughout the robot and on the feet, the knees, up in the hips, and then it will not take another step until I've hit my targets. So when someone's training to learn to walk again in this device, there's a training curve that has to happen, and they learn where their body is in space. This is now part of my own body map. And so I get the proprioceptive feedback. I'm able to make micro adjustments with my crutches on different terrains. And then it'll take another step. Did
Yeah,
I
that
answer
makes
the
sense, yeah.
question?
Yeah, and the other question I had was, what are the obstacles from making this into something that you would use, 12 hours a day, as opposed to, just for brief periods of time?
I think with the companies, with the Ekso Bionics and the engineers and any other exoskeleton manufacturer out there, as the engineering progresses so that I can do the moonwalk and the waltz and to walk upstairs. There are other robots out there that can walk upstairs, yet this is the focus on this particular device has been to mimic and perfect the most natural human gait for a bionic exoskeleton suit. But as the engineers work on the functionality, then a company like 3D Systems can work on exploring how do we individualize it. And do you want to speak to that? And the projection, the trajectory for
Yeah, we're just looking
individuality.
at all the ways where 3D printing, which is very well suited to creating an individual part for an individual person based on an individual need, how that is going to dovetail with the trajectory of Ekso Bionics, so that the machine can be more and more personalized, so it's a better fit, it's more comfortable, we can actually potentially reduce cost and weight and things like that. It's a big R&D effort that's going on right now, so this is just a kind of glimpse behind the curtain right now, but that is what we hope to achieve when we start marrying 3D printing and robotics more and more.
One of the obstacles then having it flexible enough to do stairs, do uneven ground. I'm just trying to understand, why you're not, why this particular device, what would be the version 2.0, what would be the additional things that would allow it to be more of a functional thing as opposed to just a rehabilitation tool?
Okay, so as a rehabilitation tool, I use it every day for about an hour. And it just helps me sleep better, sleep longer and harder, and to have a better quality of life. So all of the physical benefits I mentioned earlier, that's what I enjoy. To be able to take it to the next level, and that's what the company is exploring. I'm an end user. Keep in mind, I'm not an engineer, and I'm not a spokesperson for the company. So I'm Amanda, and I'm representing Bridging Bionics Foundation. So I can speak from my own experience, and what I would like to see from an end user's stance is to increase the functionality so that, yes, I can go outside and hike on uneven terrain. I can, so that the ankles articulate, so that I can stand and cook in it in my kitchen and reach the top shelf, in my kitchen cabinet. To simple pleasures, to enjoy those simple pleasures, to be able to don it for longer periods of time, have a full prevention mechanism. In all of the exoskeletons that I know of out there currently on the market, they don't have a full prevention mechanism, so that would be key to being completely independent, not always having to rely on a spotter to be with me. So did that answer some of your questions?
Okay, I think we're running out of time, or we're out of time, so I want to thank Amanda and Scott for this tremendous session. Thank you.
Thank you.
And thank you all. Enjoy the rest of the afternoon.